Hi everybody, welcome to another video. In this video I want to provide a scaffolding for your zombie project. In other words, I want to give you a little bit more structure to what we've already talked about. What I'm going to do is I'm going to give you a sort of a starting point for a Java project. You'll find that in D2L. And I'm also going to help you map out the broad algorithms that are going to take place in the zombie project. And from there, I'm going to demonstrate a couple of things, like I talked about a utilities class that is going to contain some constants and some static methods that we can use in our various other classes. So let's take a look at the Java project here. This Java project is going to contain an apocalypse class, a main class, a person class, and a utilities class. And then I have this text file called plan. That's what you're looking at right now. Let's look at the main class. First thing that I want to say about the main class is the main class should have nothing in it except for instantiating an apocalypse object and running the simulation. In other words, it should be kind of like this. Apocalypse, apoc, new apocalypse, run simulation, and that's it. Now, this is not necessarily what these calls are going to look like. In your program, you might have several parameter arguments in your apocalypse constructor. You may have some parameter arguments in your run simulation. That's totally up to you for how you want to design the project. That's not my job to tell you how to do that. I want you to decide that. But essentially, this is all that's going to go in the main. The reason for that is you want to make sure that you are putting all program essential algorithms and data into other classes. The main method should just be used to test software that you have written. You don't want anything dependent upon the main. The reason for that is what we're doing is we're designing essentially data models for pieces of software. These data models might be used with different view programs and different control programs. Okay, we might have, let's say we made this zombie program and we wanted to port it out to a PC-based GUI and control schematic. And then we wanted to port it out to a Xbox One view and control schematic, and then a PS4 view and control schematic. Well, if we put a whole bunch of stuff in the main method, then it's tied to a Java-based desktop application, and that's it. If I put a whole, like all of the game loop algorithm in the main, the only way I can run this then is through the main. I don't have any way of running it on any other platform. So we're going to keep all of the program-specific data and algorithms in other classes. This is how I want you to work from now on. We're not going to put anything in the main except for instantiating objects and testing methods in whatever ways we need to test them. For this class, all we need to do to test a method is run the top level method for our apocalypse. Okay? Apocalypse class. This is going to include all of the stuff that's going to simulate the passing of the days until either everybody has died or some people have survived the 10 days. That's what's going to happen in the apocalypse class. The person class. This is going to contain all of the data and methods that are going to be essential to the qualities of a person. Now, you might think about it this way. Maybe you can think of the person as being a place to store a counter for the number of people that are still alive. So you could do something like this. Private int num people. Okay. Maybe you also have private int food, which talks about how much food is available. Private int ammo, which talks about how much ammo a person is going to have. Okay. I'm not sure what else you're going to want to put in the person class. That's totally up to you, but I would say the bare minimum would be this. Then you're going to provide a constructor for the person. You can decide how you want to construct it. And then we're going to provide methods for sure getters and setters into string. And you can determine what else you need to put in the person class. That's totally up to you, depending on how you want to design this simulation. The apocalypse is where almost everything is going to happen. The apocalypse class is going to use an instance of person. So you need to have a person object created in here for sure. Okay, once again, this is not necessarily what constructing a person is going to look like. You might have constructors that take in values into the constructor. That's totally up to you for how you want to design it, but I'm just putting this here just to kind of get started. Okay, you might have it such that the person object is going to be constructed with 3 arguments in it, the starting ammo, starting food, and total people. But that's totally up to you for how you want to do that. When you create your apocalypse constructor, you have to determine how you're going to set that up. You're probably going to have a number of instance variables for the apocalypse class, things that you know you need to keep track of. Some examples for instance variables for the apocalypse class are going to be things like number of days remaining, number of zombies that will attack each night. By default, it has to be between 10 and 50, but you can change that to be more or fewer every night, depending on how you want to work this scenario. So you have to determine what your instance variables are going to be, and at that point, after you decide what instance variables you need, you're going to decide how you want to construct. You can initialize all instance variables in your constructor, or you can initialize some of them up at the top and then only initialize a few through the constructor. The way you want to think about it is, the constructor is going to provide any user client, like the main method, or a user for that matter, a human user, to determine how they want to set the initial conditions of apocalypse. Okay, maybe you want the user client to be able to choose the amount of food, the number of people, the amount of ammo, the number of days, the number of zombies. You want them to choose all of that stuff. Well, if that's the case, you might make a constructor that has arguments that will provide for all of those things. But once again, it's totally up to you how you want to do it. One thing that we know for sure that we need in here for a method is a method called RunSimulation. And you can decide what return type you want it to be. If you want the RunSimulation, when it terminates, it could tell us whether or not people survived. It could return true if people survived, or it could return false if nobody survived. Or if you want, you could just have it be false. It's totally up to you. I might start out just calling it Boolean RunSimulation. And the RunSimulation will return true if there are survivors. Return false if there are no survivors. Okay? This is going to be the top level of our algorithm. When I say top level of the algorithm, this is going to be the method that is going to run the whole program. And there are going to be a whole bunch of other support mechanisms or support methods in here that are going to run within this method. Let's think about what has to happen in a simulation. Okay, this is going to be our simulation. We can think about it as almost like a game loop if you were designing a game. Go to the plan document. Run Apocalypse is going to do the following things. It's going to keep on going as long as people are alive, food remains, and days are greater than 10. If one of these things is no longer true, we stop running the simulation. All right? If people are still alive and food remains and days exceeds 10, in other words, if days hits 11, or maybe you're counting down to 0 days, if days hits 0, then you've won. If there are still days left, and there are no people left, you've lost. If there are still days left, there are still people left, and no food remains, you've lost. Okay, so those are the three conditions that we're going to think about while we keep our apocalypse running. While it's running, the following things have to happen. There are two things have to happen. One, all the people need to be fed every single day. And every single day, you have to fight off zombies. I should add a little note here. Okay? Every day, the following needs to happen. Feed all people, fight off zombies. That's it. Pretty simple, right? So if we don't look at all of this text down here, if we just ignore that for a minute, this is as simple as the run apocalypse is going to be. As long as people are alive, food remains, and days is greater than 10, we're going to count down the days. And then every single day, we're going to feed all the people and fight off the zombies. That tells me there's a loop. Okay? You determine how you want to handle that loop. You can handle that loop with a while or a for. You're going to have to decide that based on how you set it up. Okay? Remember, the loop is dependent on several things: number of days, remaining food, and whether people are alive. You have to determine whether or not it's going to be a for loop or a while loop. Choose the best one. Now, here's where it gets complex. Feeding the people is simple. Okay? You could probably think of right off the top of your head exactly how that's going to happen. You look at the number of people, you look at the amount of food, you subtract the appropriate amount of food from the food storage based on the number of people you have. Easy. That's the simple part of the algorithm. Here's where the algorithm gets tough. And this is where we're going to see a lot of method decomposition. Okay? We're going to be fighting off the zombies. Now, when you fight off the zombies, here's what happens. Every single night, between 10 and 50 zombies are going to appear. And it's going to be a one-on-one situation. One person is going to encounter one zombie, and they're going to fight each other until either the zombie dies or the person dies. When the zombie dies, you decrement a zombie counter. When the person dies, you decrement a person counter. If all zombies are dead, that night of combat ends. If all the people die, well, the simulation ends. Okay? So here's what needs to happen during that fight. Generate between 10 and 50 zombies. This tells me we need a variable, right? We need a variable to store the number of zombies that currently exist. Once we do that, we need to initiate combat. Within a combat, what you're going to do is fight the zombies until all the zombies die or all the people die. Okay? So that tells me there's probably a loop. Keep going as long as people are alive and zombies are alive. So there's probably a loop there. You're going to determine what kind of loop you need. Probably not going to be a for, right? More than likely it's going to be a while, maybe a do while. It's up to you. Each round of combat consists of the following. Okay, so a combat is going to consist of several rounds of combat. Okay, a round of combat, person and zombie fight until one dies. A full combat is as many rounds of combat as you need to either kill all the zombies or all the people die. So each round of combat consists of this. Person and zombie fight until one dies. And when a person and zombie fight until one dies, what you need to do is personal attack. Now we've set up some rules based on a person attacking. If there is ammo, you're going to shoot. Else, if there's no ammo, you don't shoot. When you shoot, you have a 1 in 5 chance to hit. If you hit, you're going to check for an instant kill. Instant kill is a 1 in 3 chance of instantly killing with the gun. That's a pretty good chance. If you hit and don't get an instant kill, the zombie has 2 chances, or it has essentially it's got 2 hit points. You've got to hit it twice to kill it. So this tells me we might need a variable to keep track of that, right? Maybe we have something like a hit counter or something to that effect, that when that zombie gets hit, you decrement that hit counter. If you instantly kill it, you take 2 points off that hit counter and immediately kill it. If you miss, the person has a 1 in 2 chance of dying. A person doesn't have a hit counter. They either they survive or they don't. Okay, so if you miss, you get a 50-50 chance of that person dying. That's not so good. So that's if we have ammo. You do a gun battle. If you don't have ammo, you do a battle with some sort of a blunt object, like a board with a nail, or a baseball bat, or a table leg, or something like that. You get creative. A blunt attack is going to be like the following. You've got a 1 in 3 chance of hitting. It's pretty easy to hit with a blunt object, but it's not easy to kill with a blunt object instantly. It's a 1 in 10 chance of killing immediately. And blunt objects don't do a lot of damage. So in this case, the zombie is going to have 3 hits to kill. Once again, you might need a variable. Okay? If you miss, the person dies immediately. Okay? Now, this is the bottom level of our algorithm. Once either the gun battle or the blunt battle terminates, you're going to go back up here and you're going to fight another zombie until either the person or zombie dies. And you're going to keep doing this until all zombies are gone. Once this terminates, we're going to determine whether or not you survived it. If it terminates early because all the people died, okay, then the combat would probably return false. If you killed off all the zombies, then the combat would probably return true, okay? If combat returns true, you've survived a night. If it returns false, you haven't survived a night, and the whole simulation has to collapse. What we have here is a plan for our algorithm. There's no actual code here. There's no pseudocode here. I'm not going to write the pseudocode for you, but I want you to write the pseudocode. What you're going to do with this plan is you're going to go note by note and start writing out and fleshing out what you want methods to look like. Essentially, you can think of it as almost all of these are different methods. For example, run apocalypse. I've already put that. That's a method. And we've said that this is probably going to return Boolean. Run apocalypse. And inside there, this is going on. Okay? This might be a method here. Okay? Feed all people. And then maybe void feed people. Okay? This is probably going to be a method here, fight zombies. And maybe this returns true, or I mean a Boolean. True if they survived the fight, false if they didn't. Okay? Now, as we go through each of these points here, you're going to think about which ones are going to be your methods. Okay? And what you're going to do is determine what they're going to return. When you think about what they're going to return is you want to think about your end game. In the end, we know that run apocalypse has to return a Boolean. It's going to return a Boolean if everybody survived, or true if everybody survived, false if everybody died. Okay? You're going to think about which ones of these are going to return Booleans. And those Booleans will get passed upward. In other words, if you lost a round of combat, maybe you return a Boolean false, and if that Boolean is false, you decrement a person. If that Boolean is true, you decrement a zombie, so on and so forth. If you win a round of combat, or I mean, if you win the entire combat, you pass that up to the top level method here, and you decrement a day. That's going to be up to you how you design that portion of the program. Okay? So I think that helps flesh out the algorithm, and I think that provides enough scaffolding for you to move on from there. You're going to have to determine what the program will look like. Now, let's talk about some of the nitty-gritty details. We have a utilities class here. I just started it out to give a little bit of an example of how you could use these things. For example, start num days, start num food are two constants that you might use. Status, run, and stop. Those could be an enum that you use. And then I've got a method called generate random in range. We've seen this algorithm before. This is your generating a random between a min and a max value. And we're going to use this to generate randoms. If I just go out to my main, I can test this really quickly. in order to test it, utilities got generate random in range. This is a static method. In order to use a static method, you call it to the utilities class. And if I want to run it, let's say I wanted to go between 10 and 50. Great. That would generate my zombies. Num zombies gets that. Obviously, this isn't the place where the num zombies is going to get generated. That's going to be somewhere in your apocalypse class. You decide where that's going to go. But this is an example for how it would work. You could also use this to generate hit chances. For example, hit with gun might get utilities generate random between 1 and 5 because there's a 1 in 5 chance of hitting with a gun. You might do something like this, instant kill. With a gun, it's between 1 and 3 chance for an instant kill. With a blunt, it's between 1 and 10 for an instant kill. So that's how your static random number generator in range can work. It's pretty great. Now, magic numbers. We don't like magic numbers. These are examples of magic numbers, 10, 50. We don't know what they are or what they stand for. What you might do is do something like this. Oops. Public static int. This has to be public as well so people can access it outside the class. Public static int min zombies 10. Max zombies 50. And here's how these can be used. You can go over here and generate our zombies and go from utilities dot min zombies through utilities dot max zombies. Right? And it wouldn't go into instant kill, I would go into num zombies. Okay? So that's how we would use some of those constants. Those constants are going to be used to take the place of magic numbers. We don't want to see any magic numbers in your code. We want to see named constants to take the place of those numbers because this is more readable and more semantic. Like if I look through my algorithm and I encounter generate random number in range between min zombies and max zombies, I immediately know that I'm talking about how many zombies get generated. I hope that helps. So your utilities class is going to be full of constants like this and other static methods that will provide some sort of function for the class, but they're not necessarily tied to any instance variables. You get to determine what kind of static methods you need. You might not need any more static methods than these, but you might. Maybe you have a static method that's going to output messages, or maybe you've got a static method that's going to generate the welcome text for the simulation and the status updates for the simulation. It could be a series of print line statements in there that take some variables and output the current status of the simulation. Totally up to you how you want to use the utilities class, but I strongly recommend you use it. Utilities class is not a requirement, but I strongly recommend it because it's a pretty cool construct. It's a great place just to store these things. Let's say you get to the point where you've finished your simulation and it's now time to tweak some of these values to make it more survivable. Maybe you decide in order to make it survivable, you need fewer zombies every night. Maybe it's only between 5 and 12 zombies show up every night. Or maybe you decided that in order to survive it, the starting amount of food has to be higher, 500 starting food. Or maybe your hit probabilities for the gun and for instant kill are a little bit better in favor of the person. Well, you'll have some constants here for those, and you could just set those higher or lower. So like I was saying before, a utilities class is a great place to store all of these constants that you'll use in the program. you can very easily tweak those values to change the flow of the simulation, change the probability of survival. Okay? Now, in summary, once again, you're going to use a person class, an apocalypse, and a main class. The main class should only have creating your apocalypse object and running your simulation. That's it. Apocalypse class is going to handle everything to run the simulation. Person class is going to have everything to that the person should do and hold. Utilities class is going to be filled with all of our utilities. Refer to this plan to help you plan your algorithms. You're going to write your pseudocode in here, and then you'll eventually turn that into actual code. I hope this video and this scaffolding that I provided helps you get a better start on the zombie project. Good luck with the project. It's a tough one, but I think it's really fun and it's really rewarding. I can't wait to see them.